Autologous is when you take something from your own body, engineer it outside, and then put it back in. Allogeneic is when you take a healthy donor and you mass manufacture it and use it on everybody, right? And, our cells, because they are pre-placental cells from the embryonic stage, have pretty interesting characteristics. They have a surface marker called HLA-G that's used to dampen down the mother's immune system so that an embryo can stay attached, right? So think about this. An embryo is actually a recombination of the father's gene and the mother's gene, right? So to the mother, it's like an alien thing. It's from the outside. So how come it's able to attach itself to the mother and grow into a baby? Turns out the placenta has a role to do that. The placenta is the in-between that keeps the embryo attached to the mother. And then on the mother's side, uses the surface marker called HLA-G to dampen down all of her immune system to literally say, hey, don't worry about us. We're good, right? Leave us alone. That's how the embryo stays attached. In fact, it's so powerful that you can actually take an embryo and attach it into a surrogate mother, a woman that's completely non-related, carry the baby to term, right? So it's that same marker. Cancers later on in age, you've actually used the same HLA-G marker to hide themselves from your immune system, right? So they're using that as a marker to go after cancer today too. So, and our cells, because we're from the embryonic stage and they're preplacental, all have this marker HLA-G. And we find that when we differentiate them to a neuroprogenitor or pancreatic progenitor, the HLA-G stays. That means our cells are really ideal for allogeneic therapeutics. Yeah. We have complete immune privilege. And at the same time, because they're such early cells, we're literally able to grow them out to 85 population doublings. That's equivalent to enough cells to form 2 trillion human beings. So scale is completely selfish.